tidal flat, we discussed the supratidal, intertidal, and subtidal. Now, before I proceed further, and I discussed what are the major products of tidal flat, we said that there are the tidal channel through which tide operates, then interchannel area, then the tidal bar, and the tidal rhythmite. All this we discussed. We will one by one we will discuss what are those things and what is its importance. But before I go there, let us first discuss what is tide. Tide is a current or tide is a wave? Tide is a current or tide is a wave?
Current.
Tide is not a wave.
So it's a wave.
It's a wave, it's a current, both the answers I am getting. Now, that means it is not very clear that what is tide. Now, if you see the how really tide operates because of the, if we very simplistically, if we say that there is earth, you have a sun, and then you have a moon. Moon can occupy 4 positions. Okay, so this is sun, this is earth, and the moon is rotating around it. So what is happening is that sometimes the sun earth moon relation is like this, and sometimes the sun moon relation is linear. Okay, so these are 2 types of relation that I may get, that the sun, earth, and moon, their relationship either this relationship or linear relationship. Now, linear relationship, it happens here, and this relationship, it happens here, So accordingly, what happens, that when you have the moon, which is between sun and the earth, then the sun's light directly falls on the moon. And that is what we call the Purnima. That is the springtide. And then when the moon is here or the moon is here, that means that the sun's light directly is not falling on the moon, and that is when you have the nip tide, or what we call the Amavasya. So this Purnima and Amavasya, or the spring tide and the nip tide, these 2, they are coming at a fixed interval, and they are basically forming. So there will be spring, there will be nip, there will be spring, there will be nip. This is how the tidal cycle goes on. And this cycle, the spring to nip, this cycle, it may be 14 days. It takes 14 days. So from one spring to another spring, this what we call the lunar month. We call it lunar month. What is a lunar month? It is of 28 days. That is a lunar month. Okay. So, and what the calendar, what we follow, that is the 31 days month, that is we follow the solar month. So lunar month is of 28 days, and this lunar month, that basically controls the entire tidal system. Fine. Now, if it is a spring, if it is a nip, it is a spring, that means the tidal energy will be high, tidal energy will be low, tidal energy will be high, tidal energy will be low. Is it a current pattern you are saying, or you are a wave pattern you are seeing? Wave. Exactly. So basically, when you see this pattern, then you call that tide is a wave. But it is a very long wavelength wave. Tide is a very. Now I have a wave like this, and I have a wave like this. What is the difference between these 2 waves? That if somebody sees this wave, then this wave passes, and you can understand that there is a rise and fall, or there is a high and low. This high and low is frequently coming to his notice, that there is frequent high and low, so it is a wavy pattern. But if it is something like this and somebody is standing here, then will he experience the high and low? Because it is a very high wavelength. To him or to her, this whole thing looks like a current. Whole thing looks like a current, that there is no oscillation in it. You got my point?
Yes, sir.
So tide is a very large wavelength wave which at any particular point of time looks like a current. Fine? Okay. Now, it is the tidal wave is not that it is on the spring and nip, that I have already explained, the spring and nip. Even if you in the spring and nip, tidal current, it also has the other order of cyclicity, which is a daily cyclicity. Daily. What we call the flood and ebb, which we call the Joar and Bhata. That is flood and ebb, which operates daily. Now, again, the flood and ebb, that means the tidal wave is coming landward, that is flood, and the wave is returning back, that is wave. Now, why it will be coming towards the land? Unless the wave is rising and it is coming towards the land. And then it falls, the wave falls, and then the ebb operates, which moves towards the ocean. So there is another rise and fall history. Now, this flood and ebb, it may operate on a particular shoreline once a day, or it may occur twice a day. If it operates, that the flood and ebb, it operates on a shoreline once a day, we call it a diurnal system. If it operates twice a day, we call it semi-diurnal system. Okay? And it is observed, the more the coastline is near to the equator, you get more of semi-diurnal tendency. And as your coastline goes away, as your coastline is go away from the equator, the tendency is more towards the diurnal type. The most of the coastline near to the equator, they are semi-diurnal in nature. Now, one thing I am showing you. How is a tidal current? Tidal current is a uniform current or a steady current. It is an unsteady current or a non-uniform current. How is a tidal current? Tidal current is an unsteady current. Why unsteady? Just now I have discussed that I have a flood, I have a ebb on single day. I have a flood, I have a ebb. During flood, the tidal energy is high. When the ebb, the tidal energy is low. So even in a day, the tidal velocity changes. So that is with respect to time. If a flow is not steady, we call it the unsteady current. Okay, so unsteadiness, it is fully in reference to time, that how a flow, it maintains its character with respect to time. If it cannot maintain its own character with respect to time, then we call it unsteady. And if it cannot maintain its character with respect to space, then we call it a non-uniform. So uniformity and steadiness, these are different. Now, unsteady current. Now, I just give you one example. So this is plus V, this is minus V. And I have a tidal current that is operating. This may be flood, this may be air. Fine. Now, if this is it, because this operates on this direction, landward direction, this is oceanward direction. So I call it positive V, I call it negative V. It is because of the vectorial sense. Now, I superimpose the threshold of sediment movement, threshold velocity of sediment movement. That is, to move sediment, minimum velocity requirement. Below that, the sediment cannot move. So suppose this is the threshold movement, and this is on both the side, I put the threshold movement, TV, threshold movement. That means when the velocity is above this velocity, then, so this is the portion where the movement of sediment grain can take place. Here, no sediment movement can take place. Again, movement of sediment grain can take place here, but here it cannot. So what will happen if this is the case? Then during that time, I believe if a ripple that is moving, a bed form that is moving, and it is subjected to this kind of a flow. It is a ripple and it is subjected to this kind of a flow. So what will happen? The first, there is no movement. So if there is no movement, then what will happen? The any sediment which is in suspension, that is the muddy sediment which is in suspension, that gets settled. So I get mud suspension. And then the velocity increases and there is a movement. So as there is a movement, there will be a sand laminae, there is a movement. Again, the velocity drops and there is no sand movement. So the mud settlement will be there. Again, there is a movement. So again, there is a sand deposition is there. So what you will get? You will get either horizontal, alternate sand, mud, sand, mud. Like this, sand mud alternate sequence, which is a typical character of the tide. And this sand mud alternate sequence, it is best preserved in a subtidal setting, where by other agencies, the mud does not get eroded. What we call this one sand laminae that is bounded by two mud laminae. Each sand laminae will be bounded by two mud laminae. We call it the mud double layer. Mud double layer. Mud double layer. And each sand that will be basically bounded by two mud laminae. Is it clear, or any problem? Then you can ask me. Hello.
It is clear, sir.
Okay. So this is and it is a typical character for a subtidal setting. What happens in you may ask me why we will not get it in intertidal or in you may get it, but the problem is that in intertidal there are other agencies, other currents that may also operate, and they may erode the mud. But because in subtidal it is permanently underwater, so the chance of getting the preservation of this mud laminae alternative, it is maximum in the subtidal. Okay. Now, so once we discuss this typical character or unsteadiness of the tide, now I come on to the discussion of the tidal channel. Now, tidal channel, it is just similar to a fluvial channel. It is more similar to a meandering channel. More like a meandering channel. And the product of tidal channel will be similar to except that the grain size will be much finer. You will get mostly the fine sand, silt, mud. This will be the mostly, but the character of the channel, the product of the channel will be same. It will be a erosional base, and there will be the fining upward succession. Fining upward succession. Then how I identify it is a tidal channel? It is because of the presence of the cross stratification, which may show you the herringbone pattern. Cross stratification, which may show you the herringbone pattern. And this herringbone is basically indicator of if this is flat, this may be a, okay, so herringbone pattern. So if you get the herringbone pattern, and you may also get the presence of the lenticular bed or pleasure bed. All these that basically indicate that it is a tidal product. Okay, but all tidal channel may not preserve the herringbone cluster. If there are two tidal, suppose there is a tidal channel and there is another channel, and it is interchannel area, muddy interchannel area. It may happen that the flood operates through this channel and ebb operates through this channel. Both flood and ebb, they do not operate through the same channel. If they do not operate from the same channel, then herringbone cross stratification will not appear. You will only get one particular direction. So here in this I am getting this direction, and here I am getting this direction. But we are not getting two directions together. In that case, what we have to do, we have to measure a large number of paleocurrent, a large number of the current attributes over a large area, and then as we have studied yesterday in practical class, the Rose diagram, we make the Rose diagram, and then that Rose diagram tells us, yes, I am seeing a tidal product. Because in the Rose diagram, if you faithfully measure all the data and plot it, then the Rose diagram will show you the typical, the bipolar pattern, which is a characteristic of tidal. Bipolar pattern, because this is one direction and this is one direction, 180 degree apart. So then you call it a tidal product. So if you get it, that is very easy to identify. If you do not get it, but if you have a indication that I am seeing a tidal product, then you have to measure a lot of paleocurrent, plot it in the Rose diagram and find the bipolar pattern. Then you interpret it as a tidal channel. Okay? Clear?
Yes, sir.
Now, we will discuss the interchannel area. Now, interchannel area, that is mostly muddy. Interchannel area, that is mostly muddy. Mostly muddy. And locally it may be silty. Locally it may be silty or fine sandy. It is actually a mud dominated with sand lenticels, and the sand lenticels are mostly in the form of ripples. We get extensive the what we call the interference ripple, ladder back ripple, you get the lenticular structure, pleasure bedding. All these, that is depending on that how tide is operating, and in your environment what is the ratio between the mud and fine sand. If it is the more the mud in the system, then you get more of a lenticular structure. The lesser the mud, you may get the pleasure bedding. Now, how really we get it? two character which is very, very characteristic of identifying the tidal action. That is, you can see, that is the mud draped constrata. That is the mud draped constrata. You call it mud draped constrata. Or this is what is called the reactivation surface. You can see this is a intrabed erosional surface. Not erosional, I will not say erosional, intrabed truncation surface. Intrabed truncation surface, what is called the reactivation surface. Any question here? These are typical of the tidal product. Now, I will tell you how this intrabed reactivation surface form, which is a very characteristic of tide, particularly in the tidal bars. Suppose this is tidal bar and this is your flood tide. Okay. Now, above this bar, the ebb operates. Now, ebb really cannot, the energy of ebb is that it cannot move the sediment, but it can only rework this earlier bar. So it reworks this earlier bar. It cannot move sediment on its own. It can only rework the earlier bar. And then next flood again comes. So again next flood comes. So you had a prosthetic, then you had a prosthetic. And then these surfaces, they are the truncation surface that you said, because the truncation is done by the opposite wave that is truncated it, and then the new cross stratification again. This is how the reactivation surfaces form. Is it clear? Hello.
Yes, sir.
Okay. So, and the tidal bars are large scale bars which basically records this alternating current and their movement. So there is a large scale bar which may be mostly stationary. In very rare cases it becomes migrating. Most of the tidal bars, they are stationary. Now, I will end the tidal discussion with the final topic, that is the tidal rhythmite. Which actually forms in the subtidal, where you get the total record of the tide, and no other agency is basically eroding the record, and we are getting. So what we get, that we get the, it may be in the form of inclined cross-stratified strata, or it may be in the form of horizontal strata. Both are possible. You may get it by the cross strata or the horizontal strata. So it may be recorded in the form of the movement of a bed form, or it may be formed by a movement of the sand and mud and forming the horizontal strata. In both the ways it is possible. And what we get, that these tidal rhythmites that help us in identifying the paleotidal condition, that whether the tide was a diurnal tide, whether the tide that was a semi-diurnal tide, or what we are getting, that we are getting a lunar monthly cycle or the bi-monthly cycle. What we are getting, that all these by the measurement of the lamina thickness and their plotting, that gives us that idea. What happens really that if we measure so we go on measuring the lamina thickness. A tidal deposit, its lamina thickness is measured. And then we make a plot of lamina number and thickness. So the thickness and these numbers that are basically measured. Then we may get this kind of a curve. If we systematically and methodically, honestly, we measure this lamina thickness and plot, we get this kind of a curve where there is a high, there may be low, there may be high. So this kind of a pattern. What we see is from a high point to a low point, a high point to a low point. I may have 14 laminae or I may have 28 laminae. Depending on whether I am in a diurnal or I am in a semi-diurnal. This high we call the spring and we call this knee, then spring. So this measurement of this thickness of the lamina, what we call the tidal rhythmite, that help us in identifying the nature of tide that was operating at that place, and also the diurnal character of the tide, semi-diurnal character of the tide, and how the area has been operated by tide with tide. Okay? Is it understood?
Yes, sir.
Okay. So with this, I end the tide. We will now go to the wave-dominated shoreline. So if I summarize that how really I identify a tidal in the rock record, I will identify a tidal deposit. Number one, it should be a low energy environment. And mostly it will be muddy and silty and fine sandy. I should not expect any coarse sand, granule, pebble. This is impossible in tide. This is the first thing. Second is that if I get the proof of unsteady character of the flow operated at that place, unsteady character. Now, what are the proofs of unsteady character? If I get the mud draped cross strata, if I get the reactivation surface, if I get the herringbone cross strata. So all these, they are indicating the unsteady character of the flow. All these characters, if I get the unsteady character. And then we may also get the unsteady character I have not discussed if we study the cross strata geometry of tidal bed forms. Even the geometry of the cross strata that changes from the tabular to concave to sigmoidal because of the unsteady character of the different suspension cloud of the tide. If we get a good tidal deposit and we get the tidal rhythmite, if we faithfully measure the lamina thickness, it may give us idea about the nature of tide, nature of coastline, where I am observing the tidal product, whether it was diurnal, whether it was semi-diurnal, and all these. If we have a large amount of data, people also practice the Fourier analysis to identify the different kind of cyclicity in the data system. So now we go to the wave-dominated coastline.
Excuse me, sir.
Exactly. Hello. Yes.
Sir, is there any difference between East Coast and West Coast tidal system?
In India?
Yes, sir.
No, basically in India, the coastlines, it is not the East Coast and West Coast. It is actually the some portion of the Indian coastline, they are diurnal and some portion are semi-diurnal. So diurnal coastline, they are where the tide comes once a day, and they're the semi-diurnal. Suppose if you go to the Odisha, the famous Chadipur, there you will see that the tide it will come twice a day. So twice a day the tide comes, and then if I go to another place in the Odisha, there is Gopalpur, tide comes once a day. So it all depends upon the position of the tidal wave and the position of your coastline. The direction the tidal wave is generating, and at what direction your coastline is there. The tidal wave, if it is moved perpendicularly, then whether if your coastline is perpendicular to the tidal wave movement, you will get the two types of the tide. And then the question is that if you ask that whether there is any difference, yes, there is some difference, that is not between east coast to west coast, but between the different coastlines. That whether I have a high tidal influence or a low tidal influence. Suppose a coastline will be tide dominated or not tide dominated. That is a difference. It all depends upon the slope of the coastline. If you have a very gentle slope, then the chance of the wave abatement in the coast becomes very early, and then the tide can dominate. But if you have a high gradient coastline, there is very little chance that you have the dominance of tide. You will be mostly getting the dominance of wave. Okay? Okay. Now wave. Please let me know when you will complete the drawing. Which one? The upper figure. So it is swash and backwash. This is breaking. This is aeolian dune.
kilometers.
75 kilometer is the distance from the barn line, average distance. It is average distance. It may be not lower than that, it may be higher than that also. Average distance from the barn line to the self-slope break. Self-slope break. On average, the self-slope break that comes about 75 kilometer from the shoreline in a passive margin setting.
But we had drawn it.
Is it done?
Yes, sir.
Okay. So first I start with the lower figure. In the lower figure, the two major types of coastline situation that is shown to you. One is a passive margin, another is an active margin. If you see the figure very carefully, that the two different situation in two types. In this, you have a very gentle and gradually it is going to the deeper water. There, you are getting it very sharply and high gradient, it is going to the deeper water. So, margins are completely different. What we basically have drawn in the upper figure, that is a picturization of this passive margin setting, where you have a well-established near source situation. Well established. You may not get it properly in a active margin, where it is a very high gradient system. So our knowledge, whenever we draw a figure, that it is a simplistic figure. We always try to, because nature is not so simple. Nature, actually, I will tell you at different cases how nature varies from this figure. Nature is not so simple, but we try to make it simple so that you can people can understand the different processes, the different geomorphic setting, and all this. Now, what you can see that there is a neritic, that is shallow marine setting, and then you have a bathyal, abyssal, and hadal. So the bathyal, that basically goes up to 200 meter, from 200 meter to 3000 meter on the continental slope. So what is the general slope when you are in the shore face? It is about 0.1 degree. Shelf general slope is 1 degree, whereas slope general slope is 4 degree. This is the general slope. The shore face 0.1 degree, the shelf 1 degree, and the continental slope is about 4 degree. And you have the shelf slope break here, and then up to 3000 meter on the continental slope, you got the abyssal, and below the 3000 meter, you have the hadal. So there can be MOR, and you have an active basin. Now, if I blow up this thing, then I get this is the situation there. This is the until you go up to the self slope break. So this is an attempt to show you right from the Aeolian dune and then up to the shelf. What is the situation there? That you have, this is the sea level. So this is the sea level. This is the sea level. And this sea level where it intersects the coastline, that you call either you call the coastline, you also call it the berm line. What is berm line? Berm line is the slope break of the Aeolian dune, and that is what is called the berm line. So at the back of it is the back shore, which normally get exposed only during spring tide or storm. There is flooding of the back shore. Okay, we'll show you that what will be the different stratification pattern that I expect in the different. First, let us introduce the different zones. Then the back shore. Then the shallowest part that you call the foreshore. So the foreshore is a zone, foreshore and beach. So we call it beach foreshore. Beach foreshore. So what is the main process that is in the beach and foreshore? It is main process is the swash and backwash. That means once the waves break, then the current it generates, it moves upslope in the beach and then goes back. That is the swash and backwash. These are the two major, what we have written, the swash and backwash. That is the main process when actually what happens really, that the waves generate in the deeper water because of the friction with the air. And these waves then migrate. When the waves migrate, so as you know that there is a wave, if you have a wave, so the water that is basically in a circular motion, and if this wave then it moves here, the depth decreases continuously, and this circular motion that becomes more linear motion. Okay, and that is when the wave is moving towards the land, then you call it a shoaling, and then finally after shoaling, then the velocity anomaly in the linear that it forms, and so that is what is called the shoaling and the breaking, and after the breaking there is the swash and backwash. So this entire zone up to 20 meter, what we call the shore face zone, I will discuss in detail the shore phase also. This is what we call the shore phase, which is actually the extensive operation of the fair weather wave, the fair weather wave shoals, fair weather wave breaks, fair weather wave swash. So all these that happens in the shore face and in the proximal part. And the base of the shore face is generally identified to be the fair weather wave base, FWWB, fair weather wave base, which is about a depth of 20 meters, that we call the fair weather wave base. Is it okay or any question?
Backshore get exposed during springtime?
No. Just opposite you are saying. Backshore is always exposed. Backshore only get flooded during the spring tide or any storm. Backshore otherwise is always exposed.
Yes, sir.
And then please, because it is online and I am telling it possibly fast. So if there is any problem in understanding any part, please ask the question. Now, the shore face is that where basically what is shore face? Shore face is nothing but the zone where the wave shoals, breaks, and produce the swash and backwash. That is the zone that is referred to as the shore face. And this is an extensive zone of the wave action. You can also have some tidal effect. So there are three major processes that operates. That is the wave, storm, and tide. These are the three processes: wave, tide, and storm. Here, the wave process, the fair weather wave process, that is extensively dominant. You may also get some during the storm. Some effects of storm can also be there. Okay, we will discuss that. What will be the stratification? Beyond the shore face comes the shelf. Now, shelf has a general gradient of 1 degree. Now, what is shelf? Shelf is mostly below the fair weather wave base. So, I should not expect much of the fair weather action in the shelf. But what I expect in the shelf is an extensive working of the storm, because the shelf comes within the storm wave base. Right? Now, when I am saying I should not expect much of the fair weather, this is true as a general, but it may not true in a specific case. Suppose there is a regression, and when there is a regression, the sea level falls. When the sea level falls, then the wave base also falls. So I may have the fair weather wave acting on the inner shell. So the question is that when I define, because I am saying it is a generalized picture. If in a generalized picture, I do not expect the fair weather to act below the fair weather wave base, and fair weather wave base is the base of the shore face. But in some special cases, suppose there is a sea level fall and the total sea level is falling, and the fair weather wave base will further go down, and in that case I may expect that the fair weather wave also, I may see the effect of fair weather wave even in the inner shell. Am I clear? Now, shelf again is like shore face, which is divided into upper shore face, middle shore face, and outer shore face. Shelf is also divided into inner shelf, mid shelf, and outer shelf. So the shore face is divided that the outer shore face, middle shore face, and inner shore face. So shore face is divided into inner, mid, outer. Similarly, shelf is also divided inner, mid, outer. So what I expect in the inner shelf? Inner shelf, I expect that there will be majority the effect of storm, but I may expect some effect of fair weather as well, depending on the relative position of the sea level. And these are the two major things that I expect in the inner shelf. But I will definitely not expect the fair weather action in the mid shelf or outer shelf. Whatever be the sea level fall, it may not go up to that extent in most of the cases. So the mid shelf and the outer shelf, it is completely the domination of the storm, and otherwise it is the starved situation. We get mostly it is a shell dominated, it is a starved situation. Now first let us first blow up the shore face. Now backshore, beach foreshore, and then shore face. The inner and outer. What you are getting in the backshore, you will be getting the landward directed crostata. Landward directed crostata, which will be alternating with the plain laminated sandstone and ripple laminated sandstone. Occasional ripple laminated sandstone. So that you get in the backshore. What you get in the beach foreshore? In beach foreshore, this is the most well sorted sandstone, very well sorted sandstone, you know, in the beach, and there is a very high energy condition because it is dominated by swash and backwash. And that swash and backwash, if you all, many of you who has gone to the seashore and standing, you have seen that the waves are breaking and very fast moving current. It sometimes erodes sand near to your foot. You will feel that the sand from your foot, it is getting dislodged by that current. It is a very fast moving current, swash and backwash. So that basically is formed that the plain laminated sandstone with parting lineation and current crescent. That is a very typical of beach, and it may just oceanward of the beach we get the foreshore, where some foreshore bars that may operate. So the foreshore bars, they may form some crostata which may alternate with the beach with the minor oscillation of the sea level. The beach and foreshore, they alternate with one another. So what is product of beach? It is plain laminated sandstone with parting lineation, current crescent, and they alternate with the cross stratification formed by the foreshore bars. Now coming on to the shore face. Shore face is essentially totally wave dominated, but from the proximal to the distal shore face, the scale of bed form. So from proximal to distal, what are the changes we get in the shore face? Number one, the decrease in scale of bed form. Proximal to distal I am taking. Shore face. Number two, decrease in scale of bed form. Number two, decrease in degree of amalgamation. Number three, decrease in sand is to silt shell ratio. Number 4 is decrease in cross bed thickness. All these changes that we will be getting when we will go from proximal to distal. Proximal to distal. Okay, and essentially they are, and if you go to the distal, you get the seaward dipping cross strata. Seaward dipping cross strata. Okay, and seaward dipping cross strata, that will be very, very important in the distal surface. So if we see from the back shore to foreshore and shore face, so what I am saying that the